Hi, welcome to Physics Teacher, the channel that prepares you for the Waterloo Math and Science Contest. This is a grade 12 physics Sir Isaac Newton contest question, and in it we have Shelley, who weighs 50 kilograms, and Bob, who weighs 100 kilograms, each on a pole, one at the top and one halfway. Now they both hold onto the pole very tightly, and then the pole falls to the ground. The mass of the pole is taken to be negligible and it remains straight the entire route down to the ground. Calculate the speed of Shelley just before hitting the ground. Give it a try and I'll be right back with the solution. For this question in the contest, about 1/3 of students tried this problem, and of them only about 5% got it right. Now you could use rotational dynamics for this, but it's not required as this is a grade 12 physics contest. So what we're going to do is use energy conservation. So we have both Bob and Shelley having gravitational potential energy at this position, and then when they fall, they will both have kinetic energy. So energy conservation says the total energy must be conserved. Alright, so let's look at their initial positions. If we call Bob's initial position to be h, well, Shelley is at a height of 40 meters and Bob's halfway. So we can say Shelley's position is at a height of 2h. So first we have mgh, or the gravitational potential energy of Bob, plus mg times 2h, to be the gravitational potential energy of Shelley. Now because Shelley is at twice the height, she is going to fall twice as far as Bob. And she's also going to be moving twice as fast just before the impact. Why? Well, let's look at this motion. So it's going to be a circular motion for both Bob and Shelley. Now if Bob moves along this circular arc of radius h, then through this 90-degree angle, Bob will travel a total distance of pi over 2 times h. Whereas Shelley will travel the total distance of pi over 2 times 2h. So you can see Shelley travels twice the distance, but since they're connected to the same pole, they do it in the same amount of time, meaning Shelley is going to be traveling at twice the speed when she hits the ground. So the kinetic energy for Bob, let's call it 1/2 m. I should specify the two masses are different. So let's use capital M for Bob. So let me go back here and write capital M. Times v squared plus 1/2 small m for Shelley times twice the speed, so 2v all squared. Alright, so now we can sub in what we know. So big M here, that's going to be Bob, so that's 100 kilograms times g, which is 9.81, times the height we know is 20, because it's half of 40, plus, now we have the mass of Shelley, which is 50, times 9.81, times twice the height, which is 40, and that is all going to equal, so we can factor out the 1/2, and then we have the mass of Bob, 100, plus we have 2 squared, which is 4, so 4 times the mass of Shelley, which is 50, all times by v squared. So solving for v squared, that is going to give us 261.6. Take the square root of both sides, and we get 16.17 meters per second. Now that's the speed of Bob. So Shelley, as I said before, has twice the speed of Bob, so the speed of Shelley is going to be 2 times 16.17 meters per second, which is equal to 32.3 meters per second, or our answer is D. Now on this contest, the most popular answer was actually C, which would have been correct if Bob had not been on the pole and Shelley had fallen all by herself. However, he was there and he therefore added severity to the impact.